Welcome viewers, in this video we will see the solved problem based on the tuned circuit. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic tuned circuit problem number 2. We know that tuned circuit is nothing but connecting the capacitor in the primary and secondary side, so that we have to bring the capacitive reactance equal to inductive reactance. Both got cancelled. So the circuit behave like a resistance, that is called a tuned circuit. If capacitor connected in secondary circuit called single tuned circuit, connected in both primary and secondary means it is double tuned circuit. Now we'll see the statement of the problem. In a series fed double tuned circuit, a maximum voltage gain of 20 was obtained at a resonant frequency of 10 to the power 6 radian per second. The capacitance in the primary circuit is 20 microfarad. The maximum output voltage at resonance is 50 voltage, right? So the voltage gain is given, resonant frequency is given, primary side capacitance is given, maximum voltage at resonance also given. We need to find the four parameters. First one is supply voltage. Second one, primary and secondary self-inductance, L1 and L2. The critical value of coupling coefficient, Kc. The fourth one is capacitance in the secondary circuit. Assume that the primary and secondary resistance are 1 ohm and 4 ohm respectively, right? Supply voltage, inductance L1, L2, critical coefficient of coupling Kc, and the secondary circuit capacitance C2. One more data available is R1 and R2. R1 is 1 ohm, R2 is 4 ohm. Right. From the given data, we will calculate the parameters one by one. First, the maximum voltage gain is given. AM is 20. Resonant frequency omega is 10 to the power 6 radian per second. Maximum output voltage at resonance E0 is 50 voltage. Right. So first we will see the use the formula. Amplification factor AM equal to E0 divided by EG. Output voltage divided by supply voltage. Right. The AM value is given as 20. E0 maximum output voltage is 50. EG, from that we can easily calculate EG. Bring the EG in the numerator, bring the 20 in the denominator that side. So that EG equal to 50 by 20 is 2.5 voltage. Right. So the supply voltage is 2.5 voltage. Right. Now we'll go to find the L1 value. The C1 value is already given. 2 microfarad, that is 2 into 10 to the power minus 6 farad. So by using this formula we can find L1 value. C1 is available, omega R also available. So omega R equal to 1 divided by square root of L1 C1. Omega R is 10 to the power 6 equal to 1 divided by square root of L1 is not available. We need to find, and C1 is 2 into 10 to the power minus 6. Now square on the both the sides in order to get, so 10 to the power 6 square equal to 1 divided by, while taking square, the square root is disappear. So L1 into 2 into 10 to the power minus 6. Bring this L1 in the numerator of that side. Bring this 10 to the power 6 to whole square is denominator this side. Right. So that L1 equal to 10 to the power 12. 10 to the power 6 whole square is 10 to the power 12 into 2 into 10 to the power minus 6. So while simplifying we got 0.5 into 10 to the power minus 6. That is 0.5 micro Henry. So one parameter is calculated. L1 is calculated. Supply voltage calculated and L1 is calculated. Now we'll go for the another parameters. So next we will find the critical coefficient, maximum mutual inductance. From that we will find the maximum mutual inductance, MC. Thereafter we will find L2. So the MC equal to square root of R2 of R1 plus Rg divided by omega R. So all the values are available. R2 is 4, R1 is 1, Rg not given, say assumed as 0, omega R is 10 to the power 6. So the maximum critical maximum mutual inductance is 2 into 10 to the power minus 6 Henry. The critical value of mutual inductance, MC. Right. Now we'll go to the maximum output voltage. One more parameter is given. E0 equal to Eg divided by 2 omega R square C2 into MC. MC now we calculated. So in this all the values are known, only C2 is not known. So we can easily find the C2. Bring the C2 in the numerator this side, E0, bring the E0 in the denominator that side, so that C2 equal to Eg divided by E0 into 2 omega r square mc. See, all these values are known. We will substitute all the values. So 2.5, Eg is 2.5, just now we calculated, divided by E0 is given as 50 into 2, the resonant frequency 10 to the power 6 square, and MC what we calculated 2 into 10 to the power minus 6. So while simplifying we got 1.25 into 10 to the power minus 8 farad. So the C2 value is 1.25 into 10 to the power minus 6 farad. Now we calculated C2 also. Now we need to find the L2 value. L1 already calculated. Now we'll go for L2 value. So we'll use the same formula, omega r. But here L2 C2. Earlier we used L1 C1. Now C2 is calculated. So we can use this C2 here to find the L2. Earlier C2 is not available. Now C2 is calculated. Now square on both the side, omega r square equal to 1 divided by L2 C2. So L2 we need to find, bring this L2 in the numerator this side, omega r in the denominator that side. So L2 equal to 1 divided by C2 into omega r square. Right, C2 what we calculated, 1.25 into 10 to the power minus 6. Omega r is 10 to the power 6 omega r square. So while simplifying we got 80 into 10 to the power minus 6 Henry. That is 80 microhenry. Now L2 also calculated. L1 calculated, L2 calculated, C2 also calculated. And supply voltage supply voltage also calculated. The remaining one thing is critical coefficient of coupling, Kc value. We need to find the Kc value, one more parameter. Kc equal to mc divided by square root of L1, L2. So L1, L2 value is calculated. mc also we calculated. All the values are known. mc what we calculated is 2 into 10 to the power minus 6. Square root of L1 is 0.5 into 10 to the power minus 6. L2 what we calculated, 80 microhenry, 80 into 10 to the power minus 6. So while simplifying we got 0.32. Critical value of coupling coefficient is 0.32. Now we calculated all the values, supply voltage, L1, L2, C2, MC value, then critical value of coefficient of coupling. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.